Hello everyone. Today we are going to learn about history of C programming language. Since C programming language is tied to the development of Unix operating system, let us understand the birth of C language through operating system perspective. Let's discuss about batch operating system and its working. Back in the early days, programmers would write their instruction in punch cards and send their deck of punch cards or jobs to the computer operator. The computer operator then makes a batch of similar jobs and the CPU processes those batches in order, hence the name batch operating system. When I first heard about the batch operating system, it reminded me of photo studios of early days when mobile phones or computers were not that common. We would visit photo studio to click our photos. The operator would then ask us to visit after a week for those photos. The photo studios guys back then would make a batch of jobs. For instance, if four people have asked for a passport size photo and five people have asked for a 4 by 4 family frame photo, then the operator, a photo studio guy in our case, would prepare batch of jobs. Batch 1 for passport size photo of 4 people and batch 2 for family framed photo for 5 people and develop those photos batch wise. This is how a batch operating system works. The problem with this configuration was that it was very time consuming. Suppose I wrote a simple program using punch cards, but to compile it, I would have to send it to the operator. And when the operator finally executes those instructions, we would actually know if the code written was correct or not. If we encounter an error, then we would again work on it and bring back it to the operator, and the operator after a few days would tell us if it compiled without error. The batch operating system could not live up to the growing need of computer system. There was the necessity of alternative to batch operating system. This led to the development of time sharing operating system. The multitasking feature that we enjoy today in our modern operating system is the outcome of time sharing system. To achieve multitasking, we use CPU scheduling algorithms to allocate a time slot to each process that are to be executed by the CPU. And then the CPU execute those processes in the allocated time. Imagine a hypothetical scene where you are a student. In a good early morning, you as a student are determined to complete the first five chapters of three subjects, mathematics, English, and computer, by the end of this day. You decide to give 3 hours to each subject, that is total 9 hours. To make this 9 hour more effective, you start making a routine so that you could keep track of your progress and don't deviate from the goal. The routine turns somehow like this. After setting the routine, you look at the watch and it's 8 a.m. So as per the routine, you start practicing mathematics. Remember, your target is to complete 5 chapters. Suppose you completed only 3 chapters by 10 a.m. Now even if you have 2 more chapters remaining, but as per the routine, the allocated time for mathematics is over. So you close your mathematics books and open English book as per the routine. Let's say you completed 2 chapters of English by 11 a.m. Since the allocated time for English is over, you close your English book even if you have 3 more chapters to complete. You move on to computer subject and start reading from 11 a.m. to 2 p.m. Let's say you completed 4 chapters within the allocated time. Now, as per the routine, you start reading mathematics from 2 p.m. to 3 p.m. Remember, you only completed 3 chapters in the morning. Now you complete chapter 4 and chapter 5 in this allocated time. Similarly, by 5 p.m., you would have completed all the 5 chapters of all those 3 subjects by following the routine. The 3 subjects are an analogy of 3 processes P1, P2, and P3. Similarly, you were reading or processing those subjects. So that makes you the CPU. And the routine that you followed is the time allocated or time allotted to each process or subjects. The routine or time allotment of each process is done by CPU scheduling algorithms. And the processes P1, P2, and P3 could be any program that you are currently running in your computer. For instance, P1 could be a process of Chrome browser, P2 could be process of BLC media player, and P3 could be process of Microsoft Word. We get the feeling of running all these programs all at once due to the rapid switching between the processes. This is the concept of time sharing system. This concept of time sharing is also called multitasking. So there are three processes. CPU allocates time. Okay, by CPU scheduling algorithms, the time are allocated to P1, P2, and P3. Let's say P1 requires 3 milliseconds, P2 requires 4 milliseconds, and P3 requires 2 milliseconds to complete. CPU starts from P1, and after 3 milliseconds is over, CPU will shift to P2. CPU will shift to P2, just like in our routine. Okay, this concept of switching very rapidly between process will give us the feeling of uh, whole computer is dedicated to us. This concept of time sharing is called multitasking. The necessity of alternative to batch operating system gave us time sharing system. Since the world was running on the batch operating system, we need we needed a new system that should be compatible to both batch operating system as well as time sharing system. This led to the development of CTSS or compatible time sharing system. CTSS was the project developed by MIT. CTSS stands for Compatible Time Sharing System. Compatible time sharing referred to time sharing which was compatible with batch processing. It could offer both time sharing as well as batch processing concurrently. Okay. The password login system and the shell that we enjoy on our modern operating system is one of the few notable outcomes that we received from CTSS. Multics was another cooperative project that was going on at that time, which was also led by MIT along with General Electric and Bell Labs. The main idea behind the Multics was to create a system that can grow in size by simply adding more of the appropriate resources. In the present days, we can add more resources like RAM to build our system even more powerful. This idea of adding system together in our modern OS to grow in size is the result of Multics. The Multics project could not be fully completed due to the complexity of the system, but the concepts behind Multics still influence the modern operating system. The developer of Bell Labs, Dennis Ritchie, and his team, after leaving the Multics, started working in building the lighter version of an operating system based on the knowledge gained from Multics. This gave birth to the Unix operating system. To build a Unix operating system, they needed a language other than assembly language. So they created a new language called C programming language by improving the then existing B programming language. Here is a brief overview of what we just discussed. We started with batch operating system and then we discussed the necessity of time sharing system. CTSS and Multics are two popular time sharing systems that even influences modern operating system. Then Unix OS was built from the ideology of Multics using C programming language. Unix became one of the first OS kernels implemented in a language other than assembly language. Unix quickly became popular OS and C was the topic of interest to many developers due to its simplicity. This led to the development of various variants of C language. There was no standard of C language back then. To help the community that wanted to try C language, Dennis Ritchie himself and Brian Kernighan printed a book called K&RC. After a few years, the ANSIC C was also released in 1980 and ISOC uh, was released in 1990. NSIC was released in 1989, sorry, and in 1990 ISSC was released. After that, the new standard called C99 was released in 1999. The latest standard of C, that is C11, was released in 2011. So let us discuss about BCPL, B, C, and all these standards of C programming language. BCPL, or Basic Combined Programming Language. BCPL was designed by Martin Richards of the University of Cambridge in 1967. The main point I would like to uh, point here in this BCPL is this point. Third point, use of curly braces to delimit a block of code was introduced by BCPL. We use curly bracket to delimit a block of code in if else statement, for loop statement, function, and so on. The idea was behind it was from came derived from the BCPL language. And another thing that might be interesting to us is the popular Hello World program was written originally in BCPL. Okay, and the major drawback behind this BCPL was it only had one data type, that is word, and one word is equal to 16 bits. Okay, this was a problem in C programming language. If you may have read about it, there are various data types like integer, character, float, but in BCPL there was only a single data type, or it was simply called typeless. And B is a typeless language derived from BCPL. B was designed by Ken Thompson and developed by Ken Thompson and Dennis Ritchie in 1969. Photon was also built by the Thompson. The important point in B was here. The assignment operator reverted to this is equal to, and equality operator was replaced by double is equal to. Okay, we use this symbol nowadays, this and this, these two instead of these two. And Thomson also developed or invented the increment and decrement operator, plus plus and minus minus. And according to Thomson, B and the very old C were very similar language except for all the types in C. Okay? B was a typeless language, but C had types in it. Other than that, they were basically same in the very early days of the C programming language. So we started our lecture from this line. The origin of C is closely tied to the development of the Unix operating system. Okay, originally implemented in assembly language on a PDP-7. This one is PDP-11. Okay, uh, the before PDP-11 there was also another system called PDP-7 in which our Unix operating system was implemented in assembly language. And when there was availability of PDP-11 in Bell Labs, they switched. They tried to switch or port the operating system to PDP-11. The original PDP-11 version of Unix was also developed in assembly language, but later Ritchie started to improve B programming language, most notably adding data types for variables, which resulted in creating a new language, which was called C at that time. The C compiler was included in Unix operating system. So Unix became the one of the first operating system kernel that was implemented in a language other than the assembly language. Okay, um, many assembly language were mainly used to develop operating system back in those days. At version 4 of the Unix kernel was extensively re-implemented in C, and this is the latest news. The Linux kernel foundation is the ancient C89 standard. That means that the standard of C that was released in 1989 was used in Linux kernel foundation. But now they want to upgrade it to latest standard of C, that is 2011's or C11 standard. They are currently working on this. So the first variant of C was K and RC. Um, The standard called KNRC was actually an informal specification based on the first edition of the extremely popular book called the C Programming Language, published in 1978 by Brian Kernighan and Dennis Ritchie. Hence the name K&R after Kernighan and Ritchie. Kernighan and Ritchie. Thus the standard became KNRC because this standard was based on this book, first edition of this book. There was a little different. The C that we learned today was pretty different in the beginning. For example, let me show a function definition in K and RC standard and today's standards. We would describe or define a function like this. These data types were not included here. To declare this data type, we would write here int a float b. This was K and RC standard. But in the present days, we can declare them inside this bracket directly. Okay, and long integer and unsigned integer data types were introduced in K and RC, that is C78 standard. K and RC had 28 keywords. So this is one of the major point that many of students became confused because most of the student, if they were asked about the keywords in C programming language, they will reply that there are 32 keywords in C programming language. But what they are actually speaking is the ANSIC standard. Okay, ANSIC standard had have 32 keywords, but KNRC standard had 28 keywords. KNRC was accepted by the programmers as the de facto standard, that is by fact. But the C was not a de jure method or de jure standard, that is, it was not accepted by any standard mechanism. The the American National Standard Institute (ANSI) addressed this issue in 1983 by forming a committee, and the final draft of the standard is it formulated was released in 1989. This is the reason why ANSIC is also called C89. Okay, from here. The second edition of the previously mentioned popular book, The C Programming Language, was based on ANSIC. Okay, the first version, the first edition was related to K and RC standard, and the second edition of this book was is related to the ANSIC standard. The same standard proposed by ANSIC was adopted by ISO officially in 1990. This is the reason why ANSIC is also called as ISOC and C90. Okay, these are the standard name. ANSIC added 5 other keywords and removed one from the K and RC keywords, that is to 32 keywords. Previously there were 28 and they added 5 more, that makes it 33, and removed one from the previous one. So the total number of keywords in ANSIC is 32 keywords. And the next standard is C99. A new integer data type called long int with a minimum size of 8 bytes was added in C99. This long int data type was not available before C99. And maybe this is the most complicated thing that was introduced in C99. Variable length arrays or VLA was introduced in C99. But array objects declared as static or external storage class specifier cannot have a VLA in C. So what is VLA? We will discuss about this in more detail. But for quick demonstration, here is an example. Suppose this is a function, and when we pass and the value of n, okay, to this function, this n is replaced at here. So to declare a length, to declare an array like this by passing a variable or without knowing the value of n can be thought of as variable length array. Okay, actually array is an static data type. That means you should always specify the number here, not the variable. If I have written 2 instead of n, it meant that I required uh, 2 spaces for my two floating point numbers like 10.1 and 10.2. So we would write here 2 for that. But without specifying the number, and writing variable like this is termed as variable length arrays. And the major confusion that arises during this such type of code is that how many bytes of memory are actually allocated in the memory if you don't even know the size. Since array is a static data type, you should always specify size in the before they are compiled. So this new concept of BLE is really confusing to the beginners, but and I personally don't like these types of features. This is also an simpler example of BLA. Suppose I declared a variable int size. So when this line is compiled, 2 bytes of memory will be allocated, and printf enter size will give me a display on my console enter size. And after scanf percentage d end size, this line will, if I let's say entered 5, it will insert the value 5 in the allocated memory of this size variable. Okay, put the value of 5 that I just entered in the address assigned. Okay, the address was assigned before here when this line was compiled. Int size reserved a 2 byte memory for you. And in the next line, you can see I am declaring an array of integers with size variable name. But uh, this line should have been this line should actually reserve some fixed memory while during the compilation time. But to reserve a fixed amount of memory, it does not know how many bytes are required, because this the value of this size will only be available when the code is run, because the value of size is given by the user. Okay, there is a simple difference in compile and run. Listen carefully. Uh, Naturally, arrays are supposed to have fixed number here. Okay, no variable. You are supposed to have a number or a fixed size, so that when this line is compiled, the numbers array uh, could allocate the required number of bytes. But since the value of size itself came when the code is run from, okay, not compiled, the value of size came, the value of size is obtained when the user himself or herself give it from the console. So these types of instructions are BLAs. And this is, as I already mentioned, it is a really confusing topic. So don't worry, we will discuss about it in detail while we discuss when we will be discussing about arrays and strings. And another features like macros were introduced with a variable number of arguments. Before that, we could only describe with a single argument. Commenting style like this was introduced in C99, and the C99 also added 5 more keywords that made the total number of keywords 37. Okay, don't worry if you didn't understand BLA. This is not important for our lecture according to the IOE syllabus. And this static or extern is also, this storage class specifier is also not important on the basis of exam. So you can ignore it if you don't understand it. And the latest version is C11, which was released in 2011. The function gets caused a lot of mayhem, and so was differentiated in C99 and completely removed in C11. Okay, we use this function called gets to get a string input, but since this function had a problem with the buffer, so it was deprecated in C99 version and completely removed in the latest version, that is C11. We do not use gets function. We do not use conio.h, okay, in the latest standard. But according to our course, since the course is based on ANSIC, so we can use gets and other stuff that are already deprecated. And the concept of the anonymous structures and unions are also is supported in C1, C11. We will talk about structures and unions, and then anonymous structures and unions when we will be discussing these chapters don't worry. But unlike C99, where the implementation of variable length arrays was mandatory, okay, in the previous version C99, the variable length arrays was mandatory, but in C11, this is the optional feature. So I do not use the BLAs, okay, because it is optional, and I am currently using C11 version. And header files like std no return.h are also added in C11, and many other data types like no return data types was also added in C11. And support for concurrent programming is another important feature added by the C11 standard. And C11 also added 7 more keywords. That is, the total number of keywords in the present standard of C are 44. Okay, the 32 keywords that we are studying about is actually of the ANSIC standard. Remember that. So these were the great minds that led to the development of the Unix operating system, BCPL, C, B, and many more. Thank you for watching. I hope you understand the birth of the C programming language, and if you have any more confusion, feel free to inbox. Thank you for watching or comment.